Hi students, in this video I'll be going through the 2013 O-Level Additional Mathematics Paper 1 question 4. Alright, so this is a question related to trigo identities, and I'll use this question as an example to recap on the thought process that we can run through when we are trying to solve questions related to the proving of trigo identities. Okay, so over here you can see from this expression, it's quite clear that the left side is much more complicated than the right side, right? Okay, so for this kind of proving question, we always want to try to start from the more complicated side because it's easier to simplify a complicated expression than to complicate a simple one. All right, so the first question you should ask yourself is which side is more complicated? Okay, which side is more complicated? Okay, then you will start from the more complicated side. Okay, start from the more complicated side. Okay, so we always want to start from the more complicated side. Right, so let's start from the left side. It's obviously more complicated. So you have sine A minus cosine A times 1 plus sine A cosine A over cosine cube A. Alright, then looking at this expression that we have that's given to us, right? Okay, we need to ask ourselves the second question. Okay, what can be done? Okay, what can be done to proceed forward? Okay. Okay, so what can we do logically with an expression like this? So if you ask me one question, there's only one logical thing that we can do, which is to expand the numerator. Okay, because in the denominator we have a cosine cube A, right? There's nothing that we can do to the cosine cube A. There's no identity that is related to cosine cube A. So it will not make sense if you try to split up the cosine cube A to, let's say, like cosine A times cosine square A, and then try to apply some identity. Okay, it's just going to make the expression more and more complicated. Right, so let's expand the numerator and we will see what happens. So sometimes it's not apparent that what is going to how is it going to turn out like, but we should just try to proceed and then we will see later on whether it leads us to anything or not. So let's expand the top. We'll get sine A plus sine square A cosine A. Okay, then minus cosine A, then minus sine A cosine square A. Okay, so upon expanding, we have this. Okay, at this point, it's still not really very apparent what can happen after this or how it is going to become more and more simplified, right? Okay, but at least now you see that you have a sine square A and a cosine square A. Okay, so the moment you see sine square, cosine square, secant square A, cotangent square A, tangent square A, you should be able to start thinking about the identities. Because all the identities, most of them involve squares, right? Okay, so the next thing you can ask yourself is when you see so many squares, can I apply any identities? Okay, so this is the next question you ask yourself. Okay, whenever you see so many squares, can you apply any of the trigo identities? So indeed, we can apply some identities, right? Because sine square A plus cosine square A will give us 1. Okay, so sine square A will be 1 minus cosine square A. And likewise, cosine square will be 1 minus sine square A. And applying this sine square and cosine square identities, right, will indeed bring us closer and closer to a solution because as you can see over here, there's a tangent cube A. So tangent cube A will arise from this situation, right? If we have sine cube A over cosine cube A. So the bottom we already have the cosine cube A. So somehow we must try to make a sine cube A appear on top, right? Right? Okay, and this identity will help us, right? So you'll see, okay, so sine A plus sine. Okay, so we're going to replace the sine square A with 1 minus cosine square A, right? Okay, so 1 minus cosine square A times cosine A, then minus cosine A. So just be a bit careful when you are doing your working, don't make any mistake. So you can see over here, see this sine A times this sine square is going to give us a sine cube A already, okay, which we need to achieve the tangent cube A. Okay, so indeed it's going to bring us closer and closer to the solution. Right, so then of course, okay, let's expand. Okay, so we'll get sine A plus cosine A. So now I'm expanding all these, okay, minus cosine cube A, okay, then minus cosine A. So once again, be careful, okay. Then this time this you'll get minus sine A and plus sine cube A, alright? So over cosine cube A. Alright, then every time you perform a step, you got to ask yourself one question. Does it do anything or not? Does it do anything? Okay, to simplify the expression, to simplify things, okay? So did the step that you take do anything to simplify things? So you can see that indeed this step does a lot to simplify things, because you can see sine A here minus sine A. So that will remove the sine A. And cosine A minus cosine A, that will remove the cosine A also. That's fantastic, right? Right? So we're actually left with just sine cube A minus cosine cube A on top. Right, so that's very good. Okay, and you can see here over here in the final right hand side, there's two terms, right? So if we were to split up this fraction, then we are going to get the two terms. All right, so you get sine cube A over cosine cube A minus cosine cube A over cosine cube A, and that will allow us to show the right hand side. Okay. Okay, so this will be the solution for the first part of the question. Okay, so indeed, do try to run through these four questions as you do some practice questions for trigo identity proving questions, right? Okay, and you see whether it works out for you or not. All right. Okay, so the more times you practice, then the more that these questions will stick in your head, and then it will come naturally. Right. Okay, let's look at the second part of the question. So second part, they say hence. Okay, hence means they want you to make use of your part 1 answer. Find the acute angle A such that sine A minus cosine A times 1 plus sine A cosine A equals to 2 cosine cube A. Okay, so as you can see, this expression is very similar, okay? This one is the exact same thing as the denominator, right? Okay, sine A minus cosine A, 1 plus sine A cosine A, okay? And then over here, you have the cosine cube A. So this means that if we were to bring the cosine cube A to the left side, we will get exactly what we proved just now, right? Okay, so sine A minus cosine A times 1 plus sine A cosine A. If we divide the cosine cube A over, or divide cosine cube A on both sides, this is what we'll be left with. And this one is the identity that we simplified just now, right? Whereby we simplify it to tangent cube A minus 1, right or not? Okay, so we already proved this one earlier on. So we can replace the whole thing with tangent cube A minus 1. Okay, and this will be going to be very easy to solve, right? You bring the sorry, over here is a 2. Yeah, I was just thinking one step ahead. So bring the 1 over, then you get 3. Okay, so tangent A is going to be cube root of 3. Okay, over here they only want us to find the acute angle, so there's no point finding the basic angle. Okay, because you find a basic angle is going to be the acute angle, and then A will be equals to the basic angle. So you can actually, for 2-mark question, you can actually find the A directly, okay, by doing this. Okay, because it's already positive already. Okay, then you'll get your answer directly. So answer would be 55.3 degrees to 1 decimal place. Right, so overall, still not too difficult of a question, but do practice more questions on your own. Run through these 4 questions. So which side is more complicated? You start from that side. By looking at the expression, ask yourself logically what could be done to proceed forward. Okay, so don't anyhow use identities to sub here, sub there, and then make the expression more and more complicated. Okay, then after you have performed some steps, you ask yourself, can you apply any identities? So in general, when you see a lot of squares, cosine square, sine square, secant square, and so on, then you know that you may be able to apply some identities. Okay, then after you do anything, you ask yourself, does it do anything to simplify things? If it does not, then maybe you have taken the wrong direction. Okay, then you may want to try to look at earlier steps and see what else could be done. Right. So I hope this video is useful for you in helping you to understand more about the thought process in solving trigo identity questions.